So our next speaker is Vesna Manojlovic, who is going to tell us the story of using RIPE Atlas API for measuring IPv6 reachability.
Thank you. Hi, my name is Vesna. I'm really happy to be speaking at FOSDEM, and I'm honored to be invited here, and I'm grateful that I got a time slot of 50 minutes, because I like to talk a lot, and 50 minutes is not even going to be enough. So don't ask any questions during the talk. Just wait until I cover all of these 6 topics that I actually want to cover, and then we can do the questions and answers later. So how many of you know, have heard about RIPE? Wow, almost everybody. Okay, great. So that's going to be a really short introduction that I'm going to do there. Then I've heard already there were questions to the previous speaker about how can you get IPv6. I'm going to talk about that. Then I will cover the RIPE Atlas, so what is it, and how can you use the RIPE Atlas measurements, and then I'm going to combine that with IPv6 topic and say how can you actually do IPv6 measurements using RIPE Atlas. And in the end, I will tell you how you can take part in the RIPE Atlas community. This is my favorite topic because I'm community builder, and all these other technical details are less important than the actual community around these tools. So the main thing that you have to remember about RIPE is that it is completely different from RIPE NCC. So mostly people say RIPE when they mean RIPE NCC, but they're 2 different things. So RIPE is you, and RIPE NCC is me. And RIPE is a community of network operators that was formed in '89. It was a bunch of people who thought, this OSI stack is not going anywhere. We actually want to build IP networks, and we need to stay in touch with each other and connect our networks to each other and have this database with who is details so that we can get in touch. And so they started having regular meetings and agreeing on the things, writing right documents and so on. And then in '92, they created a company called RIPE NCC, RIPE Network Coordination Center, that was actually coordinating the work of these operators. So that's how it started, and RIPE NCC is now a company situated in Amsterdam that has about 120 employees. I work for RIPE NCC, and there's about 5 of my colleagues here in the audience today. And the policies that we implement are decided by the RIPE community. So you are the guys who tell us what to do, and then we only do it. And so the RIPE NCC is funded by the members, by the companies that need mostly IP addresses or are interested in our other products and services. So the similar things exist in the rest of the world. So on this map, you can see how we have divided the world between 5 regional internet registries. And they are very similar to each other. They're similar to the RIPE NCC. However, they have all regional small differences, and the distribution of IP addresses in all these policies are decentralized in such a way that they are different in 5 different continental regions. RIPE NCC has a main function, or it had a main function in '92 to distribute IP resources, but we also do all kinds of other things. So as I said, we give out IP addresses, AS numbers, we keep the WHOIS database up and running, but we also develop tools that are available not only to our members, but to all the communities. We work on the security and we work on the training. And on the other hand, we also operate other services that are of the benefit for the whole internet community. For example, K-root name server is maintained by us. And we take a part in internet governance on behalf of the RIPE community. And we also develop measurement tools that I'm going to talk about, like RIPE Atlas. So the students are not coming very often to our meetings, and we want to attract them, and we are now developing this cooperation with educational organizations and inviting students to come to the RIPE meetings that happen 2 times a year. Next one is in Warsaw in May. And so if you are a student, a PhD student, or if you know somebody who is doing research in networking, please apply. And we have the sponsored invitation for 5 students who will have their expenses paid to go and talk to the operators within the RIPE community and explain their work and meet the people who are interested in their work promoted that way. So please take a look at this and tell your friends that they should come to the RIPE meeting. How many of you were ever at the RIPE meeting? Okay, quite a few. Well, it's a 5-day conference, and there's about 500 people attending, mostly from ISP and telco businesses, and it's an interesting event, and it's not very expensive, so you should give it a try, even if you're not a student. So, how to get V6? So who of you has V6 at home or at work or in the hackerspace? Okay, most of you. So this part you probably know. So where do the IPv6 addresses come from? Well, basically they come from IETF. This is not on the graph, so on the top of this whole structure there is IETF, and they gave 1/8 of the whole IPv6 space to IANA, so that's /3. So IANA is then distributing allocations, huge big blocks of that space to regional registries, and regional registries like RIPE NCC allocates big blocks to ISPs, and then they give smaller blocks to smaller ISPs or to the end users. So it's a hierarchical distribution, and it makes sure that the aggregation of address space works and that the routing works. There's a lot of terminology, allocations, assignment, provider independent, and there can be all kinds of statuses that describe these objects in the RIPE database. My colleagues give the training courses in IPv6, so a part of this is from their training course material, and these courses are available to the members of the RIPE NCC, but the material is available to anybody, so you can just download this and learn all the details there. I will not dwell on the details here. So if you are an ISP, if you're a member of the RIPE NCC, you can get an allocation of the /32 size if you have a plan to start using it within the next 2 years. So criteria for getting IPv6 allocation is not really very hard. So you just have to say, sure, I have a plan, and then you will get this big chunk of IP addresses. If you don't need such a large IP space, and if you don't want to be an LIR, you can get provider-independent addresses through another LIR, through another organization, and that costs 50 euros a year. So this is another way of getting IPv6 space, but only for yourself. So you cannot make assignments to the third party. So this is just for your organization, the PI assignment. If you are not an ISP, you can still get IPv6 addresses. The previous speaker mentioned tunneling, but there is also the private IPv6 space if you just want to test it. So there are some links here on this slide. And if you are, if you have a small business, or if you just want IPv6 for yourself, for your home, do ask your ISP. And don't believe them when they say, oh, you're the first one to ask. You are not the first one to ask. And even if you are, just keep on insisting on it. And ask them to give you a large block. So up to /48 is actually allowed according to the policies. So I have with me here a lot of goodies, and some of them are these IPv6 charts that you can get from us, which explain like what is /48, how many subnets can you make from that, and so on. Again, this is not the main topic of this talk, so I won't go there. So this is one of the best handouts that we ever made. So the IPv6 subnetting chart and the CIDR chart also that explains the subnetting of V6 and V4. So you can pick them up later here. So just for the security aware in the audience, there are some security considerations that you have to be aware of in IPv6 world. And we also do kind of measurement of the IPv6 readiness within the members of the RIPE NCC. So we call it IPv6 RIPEness, and it shows per country how many of our members have asked for the IPv6 space. Did they register the route object in the WHOIS database? Did they enable reverse DNS? And did they announce their space? So if they do all those 4 things, then they have 4-star IPv6 RIPEness, and they get a t-shirt. Now, this has been the biggest enabler of IPv6 deployment in Europe, the fact that you get free t-shirt if you achieve these 4 stars. And it doesn't mean that you actually have any traffic, customers, nothing. It just means you are ready. And you can do ping. And you get a free t-shirt. So people have been actually like struggling for this, like, yes, and I have it. And so some other people, they were saying, yeah, come on, this doesn't really measure anything. So can you show us a bit more, like who is actually ready? So we developed something called 5th star IPv6 RIPEness. And if you look at this graph, on this URL, you can get it like for every country. On average, it's about 50%. So half of our members kind of got to that readiness state that they can actually do IPv6 if they want to, if they have a business model for doing it and so on. But when we measured how many of them are actually doing it, it's about 10%. And we didn't even bother making a t-shirt for that category. So we are still working on that, and yeah, this is one of the ways to encourage people to move to IPv6. How many of you actually have that t-shirt? Okay. It's yeah, great. It's a blue one. It says IPv6 Act Now. So yeah, yours is black. That's a newer model. Okay. So we have other T-shirts for RIPE Atlas. I have 2 here. They're for girls. So meet me later to get a T-shirt from RIPE Atlas. And yeah, this is another map of the world which shows where we are. We are all over the world, mostly in Europe, of course. And in the actual numbers, there is a bit more than 4,700 active RIPE Atlas probes around the world, and about half of them do IPv6. So we have almost 10,000 users, and RIPE Atlas users can do pings, traceroutes, DNS, and SSL measurements from things like this. So who can take part in RIPE Atlas? Anybody. So you just ask for one of these probes, and we ship it to you for free. If you're here, you can see me later. I have another 10 or 15 here, and you can get them from me. And you plug it in, and so what happens then is that your probe starts doing measurements towards root name servers. This is what RIPE NCC cares about. The root name servers are critical internet infrastructure, and we measure them from about 5,000 locations around the world. And we do the pings and traceroutes and DNS lookups for them. We collect all the data and publish it to everybody to use. If you are hosting one of these probes, then you can register it, and either through the web interface or the API, which I will talk about later, you can do your own pings and trace routes to any other destination that you want from other people's probes. So the fact that you have plugged in the probe enables other people to use your probe, for example, from France, to do measurements towards Brazil or wherever. So it's a truly community-driven project. It's based on the contributions of volunteers who are ready to plug this probe into their network and to contribute a little bit of bandwidth and electricity so that we can collect a lot of data. So this is the version 3 of the probe. We used to have the small little black sexy ones, like over there on the picture. And they were a bit too expensive for us, so now we are using the off-the-shelf hardware that we overwrite. So this used to be a TP-Link wireless router, but it doesn't do that anymore. So it does exactly the same as the old probe, which is pings, traceroutes, DNS, and SSL queries. It's running Linux, and that's about it from the technical side that I'm going to say here. If you want to know more, there are engineers here who are working on it, and they can get into all these details with you later. And the other box, the large one here, it's a Sucris box that is now used as a RIPE Atlas anchor. So these anchors are larger boxes that can do more measurements, and they're also used deliberately as targets for the measurements. So our plan is to have about 100 by the end of this year. We have 36 currently, and they will give us the regional baseline and what is maybe unfortunately called future history, but the longer explanation is that if we start doing these regional measurements now, then in the future we'll be able to look back and see how did connectivity in a certain region develop historically. This is actually a very good case for the countries which don't have internet exchange yet. So if you start measuring how the traffic in those countries is going all over the place and to the other countries and so on, and how when you put the internet exchange there, the traffic stays local. But with RIPE Atlas anchors and probes, we'll be able to visualize this and show it later on. So if you want one of these, you can apply, and we are still accepting applications, especially from the developing countries, let's say. So we have enough of them deployed in Europe, but we would like to see more in Africa, in Latin America, in Asia, where we don't have such good contacts. So if you have some contacts there, please let me know later on. These were the hosts of RIPE Atlas anchors in 2013. This year we have another 15 or 16. We are still working on collecting their logos, but we want to promote their organizations because they help us with the project. The difference between the small boxes and the larger one is that these we give out for free, and these your organization has to buy. It's around 800 euros or less if you can get a better deal with Sucris. So, one of the major challenges after we collect all this data is how to visualize it. So, recently we have developed in cooperation with the visualization experts from Italy, the Seismograph and the Zoomable ping graph. So the Seismograph looks like this. So it takes the 20 pings. So if you say, I want to ping from 20 probes in Italy towards the target in Germany, and it takes all those results and puts it on one graph. And then there is a lot of things that you can tweak on the controls here. So should it show you the maximums or averages? Then you can decide, actually, I don't want to see this one of them, so you switch it off. I want to see only these from the specific AS number. So there's a lot of power in this visualization that we call Seismograph. And the other one is a ping graph, which is replacing multiple RRD graphs that we used to have. So for like a daily and weekly and monthly view, we had them all separate. And now you can see it all in one graph, and then you zoom in, depending on the level of detail that you're interested in. So what are the people actually using this RIPE Atlas for? Well, there are several use cases and success stories that we had in the past. So for example, when the L-route operators have installed one of their Anycast instances in Belgrade, in the Serbian Open Exchange, then the ping graph for one of the probes in Belgrade went down. So you can see it here on the graph. So it went from 50 milliseconds to 3. And then those people in the Internet Exchange could go to their boss and say, you see, this is actually why we wanted to install the L route in this location, because now we get less latency. So then other people can go to their boss and say, this is what is going to happen. This is kind of a success story. Then some people who maintain the Anika servers for .fr, they wanted to see from different vantage points around the world how many users are querying which specific instance of their Anycast. And then they could schedule those measurements on the RIPE probes and then just see percentages and then troubleshoot and say, wait a minute, why is this one the most popular? And maybe even put some more capacity there. And why is this one the least popular? Are there any problems with that one? So they could use RIPE Atlas for this kind of research. And then finally, if there is some kind of outage event on the internet, we can see the impact using data from RIPE Atlas. So again, just a short story about the security aspects here. People ask us, well, why would I plug in a black box into my network? What does it do? So we have to keep on explaining how does it work actually. And so the probe itself has keys on it. They initiate connection with our backend servers, and then our backend server schedules the measurement to them. So once you have this probe, you do not actually have access, you don't have direct access to your own probe. You only log into the web interface of the RIPE NCC. You say, I would like to schedule pings from those other 100 probes, and then we send those commands to those 100 probes. So you don't have access to other people's probes, they don't have access to your probe either. And there are no passive measurements running on them. The code is available, it's on GitHub, of the measurements that measurement types that are running on it. And until now, we were actually very lucky to have the community that was using responsible disclosure to tell us when they found some vulnerabilities on the probes. So we dealt with that, we published it, so we are quite transparent about it. You can see reports on our security page. So with this kind of outreach to other communities and our users, we are hoping that if you find something that is wrong with the probe or that could be done better, that you will approach us first and not go and publish a paper somewhere and say, I hacked the RIPE Atlas probe. And we can promise you a t-shirt if you first come to us. So my other pet project was to go to a lot of hackerspaces and put the RIPE Atlas probe there. And then, since that is yet another community project, then people from hackerspaces.org went and made their own API and made a map of which hackerspace actually does have a RIPE Atlas probe. So you have to, if your hackerspace is taking part there, you can go to your own page on this wiki and say from the hardware, have RIPE Atlas probe, and then it's going to appear on this map. So that's quite nice too. And we have some plans for the future. Our roadmap is public, and we actually adjust it based on the requests from the community. So please let me know if you would like something else in the future for the RIPE Atlas. So finally, how does it all work? Well, the measurements are possible to do through API and through the web interface. So the API itself, well, it's just a lot of programming, so I cannot put it on the slides. I'm not a programmer, and so I'm just going to talk about like how do you do it through the web interface, but all of that, all those steps are actually possible to do through the API, and it's all very well documented, and you can find it on these links. So how does it work? Well, you have to log in. You click on My Measurements, you choose some parameters, and that's it. Then it just starts. And then there is another link where you download data. So what can you do with that data? Oh, first I'm going to talk about credits. So in order not to overload the system, we have developed something called credit system. So once you run a probe, you earn credits, and then you spend them to schedule the measurements. It's that simple. And there is like a price list somewhere on the website in the documentation section. So it says ping costs this much and the traceroute costs this much. And then when you schedule the measurement, it says it's going to cost you this and this many credits. And then there are nice graphs that show how does it decrease, increase, and whatever. The thing is, with the API, you have to provide a key to prove which user you are so that we know how much to bill you. So this is why I'm even mentioning it here, because that's a little bit more complicated. Like when you log in, we know who you are. But if you're using API, you have to first generate a key, then put that key in your API call so that we would know who has scheduled this measurement. If you want to spend a lot of credits and it's not enough how much you earn from hosting one probe, you can host multiple probes, or you can host the RIPE Atlas Anchor, then you get 10 times as many credits. If you are a member of the RIPE NCC, we have the interface which says, give me 1 million credits. You just click there and then we give you 1 million credits several times. So you can get like as many credits as you want. And if you are a researcher, then you just should talk to us and then we will give you enough credits to do your research project, because these credits were actually designed just to protect the system from overload, and we are not there yet. So, and to ensure some kind of fairness. So currently there is enough capacity, and the credit system should not stop you from doing the interesting measurements and the interesting work that you want. So please talk to us. The newest thing that we have developed is the input to your existing monitoring systems. So it's not monitoring per se, it's enabling monitoring. And so how does it work? Well, you schedule a measurement, you say, I want this website of mine to be pinged from 1,000 probes around the world every few minutes. And then you also decide on a threshold, like out of those 1,000 probes, if 500 fail, I want to be notified. And so the notification itself is another API call. So you go to this URL with your measurement ID, and then this API will tell you true or false based on the threshold that you have decided. And then you can put that into Nagios or Icinga or existing monitoring system, so that, yeah, you don't have to like rely on our tools. You already have your own tools, but the Atlas can give you inputs for your own tools. And so the documentation is online. This is not really public yet, so give it a try. It's totally not production service, so don't rely only on this, but it is a good add-on to your existing monitoring systems. And the guy who wrote it is sitting over there, so you can approach him later on. Does this sound cool? Is this what you always wanted? Yeah, great. Okay, so we have quite a few people who are very enthusiastic about the possibilities of Atlas. So they made their own hands-on tutorials, and they know what they're talking about, unlike me, because I'm like trying to promote this with the community, but they actually did all these measurements, and they made the material and the workshop and everything, and it's totally available. So take a look, like there's step-by-step instructions on how do you do this API call or that or whatever. So yeah, check it out there. We're very grateful, and if you do something like this, please let us know, because next time I'm going to put that on the slide. Finally, getting back to IPv6. So all of this that I talked about until now, of course, can do IPv6. But some people did a lot of V6 research already, so I'm just going to kind of lead you through these examples to give you inspiration on what can you do. So somebody said, well, how is the IPv6 routing happening currently? Is there filtering based on the prefix size going on? In other words, if I get only /48, can this be visible in the routing table, IPv6 routing table around the world? How many people are not going to see my /48 prefix? And the answer is about 1%. So if you do the multi-homing with announcing more specific prefix of the existing larger block, then 1% of the current IPv6 routing world is not going to be able to reach your prefix, and based on the results from the RIPE Atlas. So this has been done a few years ago, actually, so by now maybe results are a little bit different. So this was about BGP routing and the filtering there. In the DNS, some people are also doing filtering of quad-A records, and that causes unexpected problems to other operators, and we also looked into that. So a lot of these use cases are described in the RIPE Labs articles, and so all the technical details are there. The 50 minutes time slot is not enough for me to tell you everything about it. So the V6 launch day was a very good opportunity for a lot of people to test their V6 capability and reachability of their services. So they actually used RIPE Atlas to see how visible they are from the rest of the world. And some real operators gave us their feedback on what could they achieve with looking into the RIPE Atlas results. So yeah, they could actually direct the traffic to other POPs based on the results that they were getting from RIPE Atlas, that some POPs were less reachable than the others, some upstreams were less reliable than others. So they actually achieved traffic optimizations based on the results from RIPE Atlas. So that's the first example. And the second one is looking into what would happen if we switch off V4. How much of the V6 only internet would be visible? And the answer is 2/3. So that's like very simplified, and the actual details are in the article. So that means that like 40% of the dual stacked websites would not be visible if the eyeballs would have only IPv6. So if the eyeballs would not be on a dual stack network. And again, we tried some beautiful visualizations of this data, also for the V6 launch day, although this was available only to the members of the RIPE NCC. So they could go to the even simpler web interface in their LIR portal and just type in the host name or the IP address of the host service that they wanted to test. And then from 1,000 IPv6 enabled websites around the world, probes around the world, we would generate trace routes and then visualize them. So they would get two graphs, one with all the trace routes that succeeded and the other one with all the trace routes that did not get to the destination. And then you would be able to click through all the hops and see which AS numbers all these trace routes went through and who do you have to contact so they would fix their V6 connectivity. Path MTU, that was also quite an often a research project, both for our own scientists within the RIPE NCC and the students that were busy with this. So again, they found out that fragmentation indeed is a problem in the IPv6 world, and what can you do to actually fix this problem. So RIPE Atlas is also used for the IPv6 troubleshooting. So this is from 2 weeks ago. Somebody said, why is this measurement not working? And then we were like, oh, it's a bug. It should not work at all, but It actually, so some probes were sitting behind some broken resolvers, and they were like claiming to have IPv6 while it was actually not working. And then only from, I don't know, from 10 probes, 9 said, well, that target does not even have IPv6, so I cannot do IPv6 measurement. And 1 said, sure, I'll try. And then it failed. And then this guy was saying, why did it fail? And so we managed to kind of troubleshoot, and he was like, oh, I thought this website of mine had v6, and now I see that it doesn't have, so that he fixed it. So this is one of the real-life examples. And the other researcher already mentioned, Stefan Bortsmeier, he said, well, a lot of devices around the internet think they have v6, but they don't. How about RIPE Atlas probes? Indeed, the same. Some of the RIPE Atlas probes also think that they have IPv6, but they don't. So when you try to schedule the measurement from 1,000 probes that claim they have IPv6, you will never get 100% success rate because 10% of them actually cannot do IPv6 at all. So this is something that you have to take into consideration when you are examining results, that it's not always your fault. It is also the fact that a lot of eyeballs do not have working IPv6, even if they are RIPE Atlas probes. So this slide I'm not going to go through, but if you actually are interested in writing applications for IPv6, there is a lot of help over there. A lot of these URLs have a lot of helpful information. And the one that, that is my favorite is about spelling. So how do you write IPv6 addresses in uppercase, lowercase, all the possible versions of shortening the number of zeros and so on. There are some recommendations about it and very nice examples of how do you read the log files, stuff like that, when there are letters involved and colons. So to finish my talk, I will just give you a few possible ways on how can you take part in the RIPE community. So for the software writing people, there is a repository on GitHub where we collect the scripts and programs of people who used RIPE Atlas to analyze the data. So if you make something useful, please share it with the rest of the community. And this is just the graphs on how many people actually took part at which time. I didn't want to put more URLs, this is prettier. But the title is clickable, and yeah, the name is also self-explanatory. It's called RIPE Atlas Community. There you can also find the link to the source code if you would like to examine how does it work. And we have published some of our own tools for analyzing data in the same community repository. If you are very enthusiastic about spreading the love for RIPE Atlas, you can get multiple probes and give them to your friends. We are then going to call you RIPE Atlas ambassador, and we'll like you a lot. Not yet. But there is a special mailing list. So yeah, you might get a t-shirt. We are still not sure who are we giving these t-shirts to, so please see me later to get a t-shirt. It's really pretty. Look, it has a globe. If you have money to give to us, we will take it. Thank you. In that case, we will call you a sponsor, and we'll put your logo on the next slide, on the next FOSDEM, to show how grateful we are. And this enables us to make t-shirts, to actually give this hardware for free, and to ship it around the world, and not just to RIPE NCC members. And then you can get more probes for your own company, and well, you can get that anyway if you're an ambassador. But if you have money and you want to support us that way, thank you. And so we always like to ask you some questions. So, for example, what shall we do with HTTP measurements? They're technically possible on the probe. Our researchers also do them because they are careful and we trust them. but it's not open to the community yet through, the reason is, well, political sensitivity and so on, so we would like to get some guidance from the community, how should we deal with HTTP measurements. These system checks for monitoring, how much work should we put more into this, or how complicated should we make it, how easy should we make it for you? IPv6, what else shall we do? Should the data be more open, or should it be possible to do private measurements? All these questions are still open, and we are working together with you to figure out where is the RIPE Atlas going to go in the future. If you have success stories, let us know. We will put them on the next slides. And you can get in touch in many, many ways with us. atlas.ripe.net has all the information. We are on Twitter. We have mailing lists. We are going to all the conferences. And I'm very happy to be here and to take some questions.
Questions, anybody? Yeah.
Can you say you trust the data? Is there any chance that there are rogue nodes that just see the protocol and send similar data out that is completely wrong?
We do the checks. When we receive the data, we actually do the checks to see if the data is rubbish or not. So if somebody is very, very, very sophisticated and like manages to send us like the data that is almost the same as what we would expect, but it's actually rubbish, then it might happen. But until now, that was not a problem. And we have other security measures to enable only our probes to connect to our infrastructure. But I'm not saying this as a challenge. I'm just saying that this is how we check the data that arrives to our backends.
We have a SIP network, and we have Anycast with POPs in many different countries. Can we use the Atlas network to then see which carriers end up going to which actual machine in that case?
Yes, you can, because we use Atlas exactly for the same purpose, to test how the Anycast of the K-route server works. And so we have developed, because of that, we have developed maps that show exactly which instance of which Anycast server has answered to which probe, and in different colors and so on. So, yeah.
Okay. Let's thank our speaker. Oh, sorry.
So, you know, if a probe is connected via IPv4 or IPv6, did you think about distinguish between native and tunneled IPv6 connectivity?
Yes, we did think about it, but currently you cannot select the probes based on native or tunneled v6 when you're doing the measurement. So after you receive the data, you can analyze it, and there you can see what kind of connectivity the probe had, but you cannot do it in advance as of yet. But it is on the roadmap. People have been asking for this already, and well, we will work on it at some point.
Okay. I think that's it. Thank you.
Thank you.